Hello, friends. In the series of learning computer organization and design, today we are going to start a discussion on input output organization. And in this particular session, we will focus more on understanding the peripherals and various kinds of input output interfaces. So let's begin understanding this concept. So before this, this is the overview part, like which it will cover what are the various topics that we are going to discuss in this chapter. So as I said earlier, we are going to start our discussion with these two topics, peripheral devices and input-output interfaces. Here in this entire chapter or in this entire topic, we are going to discuss about what are these peripheral devices, okay, and then we will also understand about how do the communication between the peripheral devices is been done, or you could say that how your machine is able to understand the inputs from these peripheral devices. And then after this we will learn about what is this input output interface, its significance. Then we will also discuss about the various parts or the various ways in which we can interpret or define the interface in a simplified manner. So this is what is the entire agenda of today's session. And in the later or upcoming sessions, we will discuss about all these topics one by one. So let's start deep diving into these topics. So, before beginning with understanding the peripheral devices or the input output interface, one thing which is very important to understand is the meaning of this entire chapter, right? So, as the name implies, it is input output organization. Simply, it means that by input output, they are talking about various types of input and output devices available. Okay, so if I say what are the input devices, I am pretty sure that you could be able to answer this, like keyboard is there, mouse is there, right? All the devices which are attached within your machine, right, and are able to provide you the input or to provide the input to the machine, we will call them as the input components or input devices. Similarly will be the output devices. One of the very simplest example is the display device or the monitor, right? So from where we are able to generate the outputs. So point here is that how in your digital machine these input and output devices are being organized, okay, are being placed, you could say that. So, before beginning this, one thing which is very important to understand is that these two input and output devices are usually being called as the external devices. This is very important to understand because within this entire chapter, we will consider sometimes we will consider these IO devices as the external components or the external devices. The reason why we are calling them the external devices is that when we were talking about the internal devices, our basic focus was on the digital circuits, okay, and within the digital circuits we have learned that how different equipments such as memory and processor and other devices like ALU, CU, how these devices were communicating with each other. Now, these are all the internal devices which are present within the digital machine, and their way of operating is far different than these external devices. Now, these external devices, being input and output, are usually taking the input based on the human interaction, okay, like if I'm talking about the keyboard, I'm just taking one example of keyboards here. So keyboard's input will purely depend upon how fast or how slowly the user is entering or typing the input. characters, right? So this is what is the meaning of the term. So basically these external devices work upon different mechanisms. So that's why generally being considered slower in comparison to the internal devices. So this was the basic idea about the input output organization, right? Or the meaning of the term input output organization. Now let's discuss about one of the very common term or the technical term which we call as the input output subsystem. Now yes, there is a subsystem. The idea is that in this subsystem, we are basically making these external devices, okay, to communicate with the internal devices in an efficient manner. So, a subsystem is required to make this communication happen in an efficient manner. So this is what is input output subsystem. Why this subsystem is required? Because as I said earlier, these external devices are usually slow in comparison to these internal devices, which are usually fast. Now, how slow and how fast? Slow because every time these external devices need to depend upon the humans to enter the data, right? So these are internal, and why these are fast? Because these all are the electronic equipments, right? And they know that these devices will start its functionality by themselves once the entire instruction arises. They need not to depend upon any human intervention, right, for taking the input and all those things. So to work on the input especially. So that's why these are generally faster and these are generally slow. So when a slow device is to communicate with the fast, it is very important to make the synchronization between the two. So this subsystem actually works the same way. Okay, so this is what has been written here. The program and the data must be entered into the computer memory for processing, and results obtained from the computer must be recorded and displayed to the user. So the point is that when input transferred via any of the slow input device, the processor will be idle for most of the time, waiting for the information to arrive. So this is the basic reason why we are generating or we have to work with the subsystems. And this point is more elaborated when we will understand about the input output interface. So the next topic is there, which is peripheral devices. Peripheral devices, in a simple or in a layman language, are nothing but the input and output devices. Okay, input and output devices. So usually I will say that any input and an output device or the combination of input and output devices are usually called as the peripherals. Like if I am talking about keyboard, I need not to define it like an input device. I can simply say, okay, it is a peripheral device. Same is the case with the monitor, with the printer, or any other hardware equipment which is externally attached to the digital machine. I can simply name them as the peripheral devices. So usually their categories are like input peripherals, output peripherals, and nowadays with the involvement or with the evolution of the touch screens, right? So we are having the input output peripherals too, like those touch pads, which are able to take the input also and to generate the outputs also. So these are the various peripherals which are being provided here. There can be n number of peripheral devices. Just for making you understand the concept, I have just provided these few only. Now the question can also be asked to you about to describe about the various input peripherals or name any five input peripherals. Can you name them? So please try to recognize it in your mind. Similarly, any five output peripherals. And similarly, what are these input output peripherals? You just have to answer these things in your mind, because this is very a general or a specific topic, right? So next thing is the ASCII codes. So as we are understanding about the peripherals, so I thought that it is also very important to keep a little to have a little light on this ASCII codes. So Sky is a standard, like you could say that American Standard Code for Information Interchange. Means it is a standard being established by this organization. So point is that usually we say that the machine understands only the machine language, right? Or we can also call it as the binary language, which is nothing but 0 or 1. Now, my question is that when I am saying an input device is there, like let's suppose it is a keyboard, and on this keyboard, we are having various keys being present. Okay, so when these keys are present, these keys are normally consisting of alphanumerics and the numeric characters, even the special characters will be present in that. Now, the question is that I am pressing Q or any another key, okay? But this Q for my machine would not be actually interpreted as a Q only. So it must be decoded into some code, or you could say the machine code, right? So how this entire thing happens? So because this keyboard will remain same throughout the world, so that's why we are having one standard fix for that, like how this Q will be interpreted, how this W will be interpreted. So this standard is nothing but the sky standard. So basically, standard binary code for alphanumeric characters are called as the sky characters. So the idea is that usually we are considering sky codes of 7 bits. So I need 7 bits: 0, 1, 2, 3, 4, 5, 6 bits, right? So total 7 bits to determine or to interpret the sky codes. So normally within these, from these 7 bits, we can actually generate 128 characters, out of which 94 characters are considered printable and 34 characters are considered non-printable. Okay, so the idea is that usually we are saying that the Skype codes can take the data or encodes the data into 7 bits, but actually the point is that in some machines what happens is that we are taking the size of the Sky code as equivalent to 1 byte. So 1 byte usually consists of 8 bits. So what's happened is that the 7 bits will remain the same as that of this sky character, and the 1 bit, which is usually the most significant bit, okay? Usually it depicts the 0 in many systems, or it could also depict any of the special character or any of the Latin word, depending upon how the manufacturer wants to employ it. So the idea is that in certain machine, like it's been written here, sky is 7 bits, but most computers manipulate 8 bit quantity. So usually they take it as a 8 bit because it is easy to recognize, because a single unit of 8 bits is called as the 1 byte. So that's why this is how we are representing the sky codes. So this much as information is more than enough for understanding the sky characters. The reason behind making you understandable about this sky characters was that because now we are talking about the input devices and how do they communicate with the machine. So it was important to make you aware that the this is how the data is actually communicated, or the machine actually decoded its data into the binary codes. So next is very important aspect, which is the input output interface. So basically, what is this input output interface? The idea is it provides a method for transferring the information between the internal storage, okay, and the external. So idea will always remain the same. So point is that I am having the internal system and there is an external system. So now when I am talking about the external system, I am usually talking about the input output devices or the peripherals. So when I am talking about the internal system, I will basically preferring the main memory as well as the central processing unit or the processor. So the idea is that in between this internal and external organization or internal versus external system, an interface is required to have a smooth functionality or to for the smooth working of the data or the flow of the data from the external system to internal or in both ways, right? So basically why do we are using these interfaces is that these all are the reasons for it. The very first thing is when we talk about the peripherals, these are the equipments which are basically working on the functionality of electromechanical or electromagnetic devices. Like if I am talking about the keyboard, so keyboard is usually an electromechanical devices because it works on the you could say that facility of providing the pressure and some mechanical pressure over the keystrokes, right? So that's why it is electromechanical device. But when I'm talking about these internal devices being the CPU or memory, these are the electronic equipments. So it is very important that this quantity should be same. This type of the way they are operating, this should be same. So what happens? The interface helps in conversion of these signals, okay, into the one standardized signal so that the internal machine can easily understand what external device wants to say. So that's why we are looking for the interfaces, okay. So point is that now the topic is that why interfaces are required or what is the need of interface. So I told you the first need, that in order to convert the signals into the required values. Similarly, the second point is the data transfer rate. So again, as I mentioned earlier as well, peripherals are usually slower devices. Reason mentioned a couple of times now, but these CPU and memory are usually faster than the peripherals. So again, so in order to make this synchronization, we need the interfaces. So interface will help me in collecting the amount of data which is required to give ahead so that it could be accessed in a proper manner or processed in a proper way. So in order to make a sync between the two, we need the interfaces. Similarly, the third point, now, when we talk about the peripherals, they are usually taking the data in the form of bytes or blocks. Like as I mentioned earlier, if I will be pressing any key from the keystroke, it will actually convert the ASCII code, which is usually consisting of one byte, right? Or depending upon the another input devices available, maybe we will convert them in the blocks. So when we're talking about the CPU or the memory, they are collecting the data in the form of a word or the way the size of instruction is been provided to them. So that's why we need to convert the data into a specific format so that these devices can easily communicate with each other. So that's why we require interfaces. We will learn them that how these entire functionalities are met within the interfaces when I will explore you more about these interfaces in the next slide. Okay. So similarly, the next the last step is operating mode of peripherals may differ. So definitely we know that if there are various different kinds of peripherals available, each peripheral operates on its own mechanism. Like keyboard has its own mechanism of operation. The pointing devices like the mouse is having its own operating mechanism. So I need to convert these different operating mechanism into the one standard one, so that the internal machine can easily understand the kind of input being generated by these input devices. So that's why we will require, or we will need, the interfaces for them. So these are the all reasons why do we require the interfaces between these internal as well as the external devices. Now let's discuss more about the interface. So usually what happens is that these all are the input and output devices, or I will simply name them as the peripherals, right? It could be the keyboard, it could be the printer, magnetic disk, tape, and so on and so forth. And this is the processor. One point is that whenever any of the peripheral devices communicate, or want to communicate, right? So what happens is that it cannot directly access the memory. Never ever it happens. Direct access to memory is never been given. What happens is that, and how do they talk to the memory? Peripherals have to go through the processor, and the processor further takes the information or the query of the peripherals to the memory. And this is how the memory operates also. The memory will respond to the processor, and the processor will respond back to the any of the output device. So this is how the entire process takes place. That is why here we are only talking about the interfaces which functions between the processor and the peripherals. Okay, this point is very much important to understand. Now, what happens is that with each individual input or output device, we are having the interface. And from this interface, what happens is that we are usually driving the IO bus. IO is the input output bus. What is this input output bus consisting of? These are consisting of three different lines, or you could say that the three different bus lines. One bus line is the carrier of the data. Now, which kind of data we need to reflect in the processor, or it is also contributing to the analyzing the address, at which address we need to point out. And it is also having a control line, so it will depict that the control over that particular data, what is the status of the data. So all these things would be done. So usually what happens within the interface is consisting of IO bus, which is responsible for carrying three types of the lines or the buses or the lines, right? One is the data line, another is the address line, another is the control line. Now, what happens or what are the jobs of this interface? The job or functionality. It decodes the device address. So that address will be decoded and go from this address line. Okay. And it decodes the commands or the operations, what to do with the data and what kind of operation we need to perform. So it will able to take the data actually, provides the signal for the peripheral controller. So control line will be there, synchronizing the flow of data and supervises the flow, the transfer of the data between the peripheral and the memory, right? So this is what is the functionality of interface which it serves between the peripherals and the processors. So usually what happens is that how this entire functionality is taken into consideration. There are four different types of commands which are available within this interface. One is the control command, then is status command, data output command, and data input command. So let's understand about them in more detail. So when we talk about the control command, so what does this control command will do? It will actually issue the you could say it is issued to the to activate the peripherals. Control command means which particular peripheral wants to take the control. Okay, like whether it is keyboard or it is magnetic disk or it is the printer or what kind of device want to take the control. It will simply activate it and also will inform what this particular peripheral want to do and which operation this peripheral want to perform. Okay, so this is what is the purpose of the control command, to analyze this thing. Then there comes the another command, which is the status command. It basically used to test the various conditions. Like a peripheral is something like it has to be in the ready state sometimes, it has to be in the waiting state sometime. It's not like whenever the system or the peripheral got activated, it is ready to transfer the data. No, it may have to wait for the processor to get free also. So that's why the status command is there. Similarly, there is the data output command. So it causes the interface to respond by transferring the data from the bus into one of its resistors. So basically, what happens is that, so within the interface, we will be having the data output command, which will simply depicting me that to transfer the data. But how to transfer the data? Some data will be available in the register, which is present in the interface. From there to the to transfer it over the bus to carry the data. I would simply say the same is the thing here in data input command when we are to provide the input or to provide the data, so interface will receive the data. Okay, so idea is that within the interface we are having a resistor. Okay, so this resistor will be consisting of data. One thing is to put the data here on this interface. So in order to put the data, data input command will be there. In order to take out the data, to transfer the data, okay, over the bus, because after this interface, what is happening? To talk to the processor, we are having the IO bus only to carry the data, right? So on this data bus, we will be transferring this data which is available in this resistor of the interface to move ahead. So this is how the four commands of the interface will help us to make the communication successful between the peripherals and the processor. So usually what happens is that this is just a little bit off topic from here. So we will also discuss about the input output bus and the memory bus. We have learned that there are peripherals, okay, there is a CPU and there is a memory. So the point is that one bus, that is the IO bus, is required between these peripherals and CPU, and a memory bus will be required to transfer the data from the processor or to the memory. Now, what happens is that there are usually the three ways through which the memory and input output devices can communicate. So, what if they want to communicate? So, how we can do that? So, one point is that we can use two separate buses like this. This is the first point, like we are using it, right? So, the first way is that we can transfer the data the way it is. The two different separate buses have been there. One is for this particular till here, and another is for CPU to the memory. Now, second thing which we can do is, or which the manufacturer can do is, they can use one common bus for the memory and IO device. So, a one common bus can be there, okay, directly. But the control lines would be different, because to control the data in the memory, that we will require some different, because memory we can perform only read and write operation. So in order to control the data here, we can have a separate line. To control the data here on this peripherals, we can have a separate line. So common line for we can use one common bus line, and the control line we can differ. So on this common line, what we can have the data and the address pin same, okay, for both peripherals and memory. The another aspect that where we can work upon is we are using only one common line for the IO devices with the common control lines for both. So we are not using any of the control lines separately. Third is that on the one common control line only, we are just able to do anything. So depending upon the way we want to use this peripheral with the memory, okay, means the functionality or the application that they want to perform, accordingly we can make the communication to work in these three ways, okay. So another aspect is again there with the with respect to the memory only, right? It is the isolated versus memory mapped input output. Now, isolated input output simply means that isolate means alone, alone input output, right? So, in the isolated input output configuration, the CPU has its distinct input output instructions, and each of these instruction is associated with the address of the input register. So, means we are having a separate line. So for carrying the data from the peripherals to the processor, one separate line will be required, which is having its own input and output instructions being available. But when we talk about the memory map IO devices, so what happens is that we are using a set of control lines. You could say one common control lines for IO as well as for the memory. Why so? Because its name is memory mapped. We have mapped the peripherals within the memory line. So that's why. So both memory and IO addresses share the common address space. So it means each and everything will be shared. There would be a common line between the memory and the in IO devices. In the isolated IO, so isolated IO can only talk to the processor or the CPU for that. So we will be having a separate line to distinct the instructions which we want to present to the processor. So this is how these two terminologies may vary. So the question can be like, what is isolated input output and what is memory map? Then you should know that common line is been there, and common line for what? For everything. We are having a common line. Okay. In case of IO, so we will depict that a separate lines, a distinct input output instructions will be provided. So this is the basic thing. So in the last, this is one example to depict how this entire thing works. So these four are nothing but the commands that we have just learned, or you could say this is nothing but the interface. Okay, this is the interface. So what happens is that we are having a status register. So status, in order to determine the status, now each of these commands will actually be having depicting its status through the registers only or with the flip-flops. Like for the status, I could be saying that okay, it is only a one bit, or a flag has been there, or a flip-flop has been there. So usually we call them as the register, but otherwise it could be consisting of one bit of data. So control resistor will be there. Port B is here for taking the input output data. Either the device is there for taking out the data, or port A is again there to taking in or taking out the data. So दोनों के लिए we are using the port A and port B for taking the data, inputting the data, and for output the data. So idea is that this is the timing and the control signal. Depending upon the values of this timing and control, this entire interface will start functioning accordingly. So here are the IO devices and this side is the CPU. So what happens is that this is a chip select. If it is enabled, only then your entire interface will work. See, if this is CS is equals to 0, whatsoever value this RS0 and RS1 is having, nothing is going to happen. So now let's introduce you with this RS0 and RS1. This is the resistor select. So usually here we are having four resistors. So two lines are required to select the appropriate resistor. Got it? So if the CS value is 1 and resistor select is having the value 0, 0, so what will happen? The port A will be selected, and it will be able to perform either to input the data or to output the data. Okay. Then similarly is the next. If chip select is okay, or you could say the activated, and the resistor select values are 0 and 1, then port B will be selected. If it is 1 and 0, C, this control resistor, for 1 1 the status will be selected. So accordingly they will be placed on the interface bus or the internal bus, and will take the data from through this bus buffer to the CPU. This is how the entire communication will take place. With this, I hope that you have understood today's session, and thank you so much for watching this session. Thank you.